Good morning, everyone. Today, I am going to present my topic on H2O2 fuel cell working and applications. I am Sanchi Shinde and I study in FY BTech Class E. So, first of all, let us understand what a fuel cell actually is. A fuel cell is an electrochemical device that converts chemical energy directly into electrical energy. Unlike batteries, fuel cell can continuously produce electricity as long as fuel is supplied. In this presentation, we are going to focus on the hydrogen peroxide or H2O2 fuel cells. Hydrogen peroxide is commonly known as chemical used for cleaning and disinfecting purposes, but it can also act as an energy source because of its strong oxidizing nature. H2O2 fuel cells are gaining attention as an alternative energy technology because they can produce electricity efficiently and with lower environmental pollution. These fuel cells convert hydrogen peroxide into water and oxygen through electrochemical reactions. Compared to the traditional fossil fuels, these are considered cleaner and potentially safer for certain applications. Researchers are exploring them for portable devices, transportation systems, military equipment, and even aerospace technologies. The main reason scientists are interested in H2O2 fuel cell is because they have high energy density and can start quickly without any complicated systems. This makes them suitable for emergency and remote applications. So overall, H2O2 fuel cell represents an innovative step towards cleaner and more sustainable energy systems. Now, let us understand the working principle of H2O2 fuel cells. The operation of these fuel cells is based on electrochemical reactions. Inside the fuel cell, hydrogen peroxide undergoes chemical reaction that generate electrons. These electrons flow through an external circuit and produce electrical current. A fuel cell mainly has two electrodes, anode and cathode. At anode, hydrogen peroxide gets oxidized. During this process, electrons are released. These released electrons travel through an external circuit, and this movement of electrons produce electricity. At the cathode, oxygen reduces reaction take place. The cathode accepts the electrons from the external circuit and completes the electrochemical reaction. As the reactions continue, hydrogen peroxide is ultimately converted into water and oxygen. One important advantage is that the byproducts are environment friendly compared to the harmful emissions from fossil fuels. The electrolyte inside the fuel cell helps in movement of ions between the anode and cathode, preventing direct mixing of the reactants. Overall process can be summarized in three steps. Oxidation at the anode, electron flow through the circuit, and reduction at the cathode. This continuous process generates energy efficiently. Another interesting point is that H2O2 fuel cells can operate at relatively lower temperatures compared to some other fuels. Because of this, they can start quickly and become operational in short time. Therefore, the working mechanism of H2O2 fuel cell is simple, efficient, and suitable for modern and clean energy applications. Let us look onto the diagram. So, as we saw the diagram, let us discuss the major components of H2O2 fuel cell. There are mainly four components: anode, cathode, electrode, and catalyst. The first one is anode, and the anode is the electrode where oxidation occurs. Hydrogen peroxide reacts at anode and releases electrons. Second is cathode. Cathode is the responsible for reduction reaction. It receives electrons from the external circuit and helps complete the electrochemical process. The third is electrolyte. The electrolyte is very important because it allows ionic conduction between the electrodes. At the same time, it prevents direct mixing of the reactants, which provides efficiency and safety. And the next comes, which is catalyst. Catalyst increases the speed of chemical reactions without getting consumed themselves. In H2O2 fuel cell, catalysts such as platinum and magnesium oxide are commonly used. Platinum is highly efficient but expensive. Magnesium oxide is cheaper and is considered a more economical alternative in some applications. The performance of a fuel cell depends greatly on the quality of these components. Better catalysts and electrons can improve efficiency, durability, and energy output. Another important factor is that electrode material design. Scientists are continuously researching advanced materials due to reduced cost and long-term stability. So each component plays a critical role in ensuring that the fuel cell operates efficiently and safely. Without proper coordination between these components, the fuel cell would not be able to generate electricity efficiently. Now, let us move on to some applications of H2O2 fuel cell. Due to their high energy density and quick startup capability, these fuel cells are useful in many fields. The first application is portable power source. H2O2 fuel cells can provide electricity in remote areas where conventional power supply is unavailable. They are useful during emergency situations and disaster management operations. The second application is transportation. Researchers are studying these to use hydrogen peroxide fuel cells in electric vehicles and clean transportation systems. Since these produce cleaner emissions, they can help reduce environmental pollution. And another important field is aerospace. In this space missions and aerospace systems, compact and efficient energy sources are very important. H2O2 fuel cells are being considered because they are lightweight and designed to be efficient and power generation. They are also useful in military equipments. Military operations often require portable and reliable energy systems. In addition, these fuels may be used in underwater systems and submarines because hydrogen peroxide can act both as oxidizer and energy source. Scientists are also exploring their applications in backup power systems and renewable energy technologies. Therefore, these fuel cells have a wide range of applications in both civilian and industrial sectors. So, what are the advantages and challenges? The first advantages is that it gives high energy density. H2O2 fuel cell can store and deliver a large amount of energy in a compact form. Another advantage is that the quick startup time. Unlike some conventional fuel cells, they can begin operating rapidly, which is useful in emergency applications. These fuels can operate efficiently at lower temperature, reducing the need for complex thermal management. And however, there are also several challenges. The biggest challenge is that the stability of hydrogen peroxide. It can decompose It can decompose quickly. Also, catalysts such as platinum are very expensive and may lose efficiency after prolonged use. Safety management is also important because concentrated hydrogen peroxide can be reactive if not handled properly. So, while there are challenges, the potential benefit of this technology is very promising for the future and the cleaner generation. Thank you.